you like delving deep into things that no one else would like to do. Chrome internals, no thank you. Yes, you spoke at ConCon last year, didn't you?
Yeah.
And so we wanted him back. So welcome, Chris.
Let me check. Is that full screen? Yeah, it is. All right. Yeah, thanks for having me, and thanks for staying out that long. I know that it's the last talk, so I'll try to keep it as entertaining as possible. The title is No Feedback Welcome, as Dan already said. And that's not true for the talk, it's just a title. So if you have any feedback, you can hit me up afterwards. I would highly appreciate it. And if you want to follow along yourself, you can find the slides on that URL. But you don't have to do it right now. The link will be on the last slide again. Yeah, as Dan said, my name is Christoph Guttandin. I'm from Berlin. I build multimedia applications for the web. And oftentimes I hit bugs, which I then try to figure out what's actually happening. And this is basically one of those stories. And yeah, quite recently I became part of the audio working group, which is not responsible for the spec I'm talking about today, which makes it a bit easier for me to criticize it. I did not bother to look up for an official definition of feedback, so I just made up my own, and you can see it over here. I would say feedback is something when you have a system that has an input and an output, and for some reason you connect the output back to the input, then that's feedback. And I made this drawing yesterday, so the setup is a bit different today, but the idea is that you see me here and you see the slides and the speakers. We don't use that speaker, we use that one, but we actually would get feedback if that speaker would bleed into the microphone and I would speak into it at the same time, and then it would create an infinite cycle. And I think we heard a little bit of this early in the morning, but hopefully not in that talk. And yeah, that's actually the sound is like a high frequency sine wave, and the feedback that I think most of you often deal with is more like this, that we have a conference call with a typical office setup and a person sitting in front of the computer speaking into a microphone, which could be on the computer or a different device, and then audio is coming out of the computer as well. And the audio from the remote party gets picked up by the microphone, gets sent back to the remote party, and yeah, causing an echo there. So it's not that immediate feedback that would cause this high frequency sine waves, but it's more like an echo, which is very annoying if you speak and you hear yourself with a slight delay. Just for the sake of completeness, there's of course also video feedback, but yeah, it's annoying as well, but not part of this talk. The easiest fix one could think of is just wearing headphones, like fixing it with another device. And if you just cut the loop, the infinite loop, and have the sound coming out of the headphones, then nothing can happen because no one can hear the sound from the remote party. The microphone can't pick it up, and so yeah, no feedback will be heard. But we are software developers, so we can fix everything with software. And that's actually true for feedback as well. There's an algorithm called echo cancellation, and the idea behind this is it's actually also an audio effect, less cool than the things that Evan had in his talk, but still yeah, quite nice. And this is that in this example, you can see an input on the top, which is what we kind of expect to get is the gray line, but for some reason we get the orange line. And this is because we also have an output at the same time, and that's the orange line below. And what we can do with it, we can just flip the output, add it back to the input, and when done correctly, of course it works correctly because it's a slide, we will get the sine wave that we expect to get. But the tricky part with it is that we have to do it really, really precise to get the expected result. If we do it with a slight offset, we might end up with this, like it's the same algorithm doing that, just with the wrong offset, and the result is actually not much different from the dirty version that we had before, running the algorithm, we just get the same, or more or less the same result. And the reason for that to happen in the wild is that microphones and speakers and rooms, they all have certain characteristics and they are never perfect. And the signal will be distorted and you will never get the same output back again that you had on the audio device when sending it to the speaker. The microphone will never get exactly the same signal. So the algorithm is not as nice and as clean as shown in this example. It's actually very complicated. But all we have in the browser is just a Boolean property to turn it on and off. The specification actually doesn't say anything about the algorithm. It just says it enables echo cancellation or it doesn't, and that's it. There was an effort to make this a bit more descriptive a while ago, but it didn't go anywhere. And yeah, to make it even more complicated, that's not only the complicated algorithm, it's also the kind of output we choose as the input or as the source for the algorithm can vary from browser to browser. Like you can, for example, only use the audio of the current tab, and that's what Firefox is currently doing. And Chrome did a similar thing for a long time. They used the audio of the current tab, but only the one coming from a remote WebRTC connection. And that's actually what got me interested in that's a problem. That's how I encountered it. If you use the same stream, piped it through the WebAudio API, and it came out on the other side, it was not part of the echo cancellation algorithm anymore. And that changed last summer. It was rolled out, I think without any public announcement, and there's a new flag called Chrome-wide echo cancellation, which was a trial at the beginning, and now it's on by default, but you can still disable it if you like to. So Chrome is now doing this, that it fixed the bug, but also made the implementation different from Firefox, that it's now canceling the audio of the full browser, which means if you play something in a different tab, it's also part of the source that gets into the echo cancellation algorithm. And yeah, Firefox does the tab, and Safari, of course, does another thing. It uses the full system to cancel the audio. And last but not least, there are also devices which have this wired in hardware, and you cannot even control it. I use a laptop here in the graphic, but I never saw a laptop doing this. This is mostly smartphones doing it. Yeah, just to summarize, the reasons why people do this is to get better sound, and this is of course an opinion. Like maybe you get better sound, and of course it's annoying when you have speech and you hear yourself speaking again just a few milliseconds later. But it also has some disadvantages, of course. But it may increase privacy. For example, the reason, as far as I know, for Safari to use the full system is that they say that if you have other sounds playing on your device and you get these sounds as input and send it to a remote party, you might reveal things that you would not want to reveal. So for example, if you get notifications on a messaging app or something, then the remote party knows that you are using that application. And they could even trigger some messages to kind of guess if you received them, or if that account that received the messages is actually your account, and yeah, things like that. And the downsides, of course, it increases the latency because it has to be done somehow, and that takes time. If you enable it, Chrome is the only browser which tells you the numbers. The latency is then 10 milliseconds, and if you don't use it, you get the 128 samples. That's probably coming from the WebAudio API because that's the default render quantum size. And yeah, that's the same. Another bullet point on the list is actually the opposite of the thing that I said before. It's lowering the sound quality, and that's actually depending on your use case. Like if you have this normal conference call, conversational setup, then it might increase the quality. But if you have a call with a lot of people talking, and they might have similar voices, yeah, the echo cancellation might actually get confused and might cancel some of your sound because it's thinking it's coming from the remote party, and that's causing very choppy sound, and yeah, might actually get worse than it was before. And yeah, then the last thing is kind of a generalization of that. Like there are a lot of usability quirks. If you, for example, are on a call and somebody plays something just to, like, for example, I work on a lot of audio apps and people sometimes call me and then we are on a call and they just play something for me to hear it and I can't hear it, and then it's always confusing. Like, can you hear it now? Is it cancelled? Is it not? Do I have to share the tab? If I have to share the tab, do I have to enable audio, and so on and so forth? So it's very much tailored to the conference call use case. But as Dan said, I gave a talk last year. It was about testing, and this talk is about testing too. Like, if you have something in the browser and you cannot really be sure if it's different the other day, what I like to do is write a test to verify that it's still the same. And for that, I came up with a super simple website which plays an AI-generated sound. So there's also some AI in my talk. It's the most common sentence in every call. Let's see. Oh no. Why is it not working? Oh shit, I stopped the server. Let me quickly get it up and running again. No. It's hard to type. Oh. Where is it? There it is. So, should be back. So here it is. No?
Hey, I think you're muted.
Yeah, now you heard it. And I can then record that. And
Hey, I think you're muted.
analyze it. And
Hey, I think you're muted.
that's what it just recorded because the echo cancellation was not enabled. And it should give me a result. It's highly unoptimized, so it takes a while. It does cross correlation with the audio. And now it tells me it's around 0.3 is the result. Like, the correlation is from 0 to 1, and 0.3 is actually a very good result because it's, as I said, the audio is very much distorted if it travels around the room. But if I enable the echo cancellation now, it should be better.
Hey, I think you're muted.
Yeah, you heard the recording that was played back when I had pressed the analyze button, and now, yeah, the correlation is still a bit, but it's less. And yeah, if you do this in a quiet room, in a smaller room, you actually get better results. Then it's more like 0.5 for the uncancelled version and more like 0 for the cancelled version. And you can then just take that and run it with a browser automation thing like Playwright or Puppeteer. Open it in the same tab, open it in different tabs, open it in different browsers to actually get the results that I just mentioned when I showed you the different versions, like which browser is canceling only the tab, which browser is canceling the full browser, and which browser is actually canceling the operating system. Yeah, I think a talk about echo cancellation would not be complete without mentioning noise suppression, which is kind of the same thing, but actually very much different. Echo cancellation has the source that it's using as the input, and noise suppression is actually even more magical because it works on the assumption that it knows what noise is and then removes that. And we also have this Boolean property to enable it, which can be either true or false, and yeah, that's all we have. And the way it works these days is that it's working with machine learning, of course, and I think RN Noise was the first version or first project which did that approach, that they split the audio in frequency bands, a bit like a band band equalizer, and then trained the equalizer basically to move very, very fast to cancel noise. And this is even more subjective than echo cancellation because who knows what noise is? It depends on your use case. If you develop a baby phone, for example, and the model that you're using cancels baby sounds, then it's probably useless, or even worse, it's not giving you the cues that you want from it. Yeah, though this is even more tricky than echo cancellation. Yeah, and I assure you, I made this slide before I heard the talks of today, but I think this is the future, like that we end up with AI on both ends, and we have some kind of speech-to-text thing on one end and text-to-speech on the other hand. And yeah, we could just modify whatever we want. Like you could be on the beach on a call with your colleagues, pretending you are in an office because you generate the sound as if you would be in an office or things like that. And yeah, the end is the very same as last year. I still think that the web is a moving target and we need to test it or write tests, automated tests to see when it's moving. But yeah, the good thing is that we can actually move it ourselves from time to time if we really want to. That's it. Thanks.